Saxon's Trig, lesson 104, is about arithmetic series and geometric series. And I like this one because there is a fun story to the mathematician Gauss, who came up with the arithmetic series. So when he was in elementary school, and it was a one-room classroom kind of thing, and they only had a little tiny piece of slate, chalkboard, and the teacher was tired that day and he just didn't want to deal with the students, and so he decided he was going to give them busy work that would take them all day to solve. So he said, I want the answer for all of the numbers from 1 through 1,000, the sum of all of those. And he expected them to have to write 1 plus 2 plus 3 and then only get a little answer and then have to erase it and then keep going, and that it would take them all day to accomplish that. Well, within just a minute or two, Gauss came up and handed the teacher his slate with an answer on it. The teacher got mad. He yelled at him. He's like, there's no way that that's right. And then he checked it and realized that the kid was right. And now he's even more angry because this kid has accomplished it. And so he asked him, how did you possibly do this without it taking you all day long to calculate? And he said, well, you told me to basically take all of the numbers 1 through 100. And so I was looking and I was seeing, oh wait, if I take 1 plus 100, that gives me 101. If I take 2 plus the 99, oh, that gives me 101. If I take 3 plus the 98, oh, and then he just said, okay, so I half the amount of numbers that I have here and I multiply that times 101, boom, I had my answer for all of it. The teacher was absolutely flabbergasted. But the end result was that we have a formula for an arithmetic series. So it's the addition of all of the numbers being added together. And then for a geometric series, it would be the multiplication of all of the numbers being multiplied together. So on the top of page 587, you have the formula that childhood Gauss basically came up with. So if you're supposed to add a series of numbers together, you're going to take however many that was and divide it in half, because that's how many sets you're going to get of the first number plus the last number added together, and then do that half and then the multiply. So that's the arithmetic formula, series formula that you need. In example 1, it says, an arithmetic sequence has the first term of -10, so a sub 1 is -10, and a common difference of 20, the difference is 20. Use the first 4 terms of the sequence to write a series. So it wants the first 4 filled in, and then develop the formula for the sum, and then use the formula to find the sum of the first 11 terms of the sequence. Now, we already know what the formula is, but we're going to try to do what they asked. So the first one is -10. I'm adding 20, so that takes me to 10. Adding 20, that takes me to 30. Adding 20, that takes me to 50. And we want to add each of those up using our, okay, so now that we've listed them, you're going to use, because I needed the first and the last, so use the formula. There are 4, so 4 divided by 2, add -10 and 50, that's going to be 40. 40 times 2 should be 80. I was looking for their answer there. Okay, and then it jumps to find the first 11. Okay, so I would need to know what the 11th term was. And then to do that, I'm going to need to follow the formula, which tells me a sub 1, which is -10, plus, and how many differences do I need? 11 minus 1 is 10, times the difference, which was 20. So 200 minus, so that's the 11th term is 190. 90, yes. So now we're going to follow our formula here. We're going to do 190 plus our negative 10, or flip that technically, first one plus the last one. And then how many terms did we have? 11, dividing it in half, and that will be 180 times 5.5 basically. When you calculator that, you should get 990, because I can't do that in my head. Now that we've practiced with the arithmetic series, let's do the geometric series in part B. And that one is slightly more complicated. I'm gonna, the proving of it is basically you would make a list of your numbers and then shift everything by 1 unit and subtract, and cancels off a lot of things. And so what you're left with is this. A sub 1 with your 1 minus r to the nth power over top of 1 minus r. So again, coming up with this formula isn't as nice and simple. Now they do try to show you how they're getting there in part B. If you wish to study that, by all means. But I'm going to jump you straight to the formula, and this is how we do the geometric. So in example 2, it says develop the formula for the sum of the first n terms of a geometric series and use the formula to find the sum of the first 9 terms in the geometric series whose first term is -8 and the common ratio is -2. So the first term is -8. The ratio is -2. We are not going to develop the formula. We're going to use the formula provided to find the sum of the first 9 terms. So we want 9 terms. A sub 1 is the -8. 1 minus, the common ratio was -2 to the n, so the 9th. I'm going to change that. I don't want the parentheses getting blurred together. With 1 over -2. So now simplify -8. All right, to the 9th power, I know that's going to be negative. Negative and negative then is going to be a 1 plus 2 times, okay, it's easier on the calculator. Let me see if I can do it in my head. 2 times 2 is 4, times 2 is 8, times 2 is 16, 32. Oh, no, I'm going to get way too big for me to handle it. Okay, so, all right, I'm going to jump to what the book told me, which was that it was 512. Your calculator would give that to you. And the same thing here, 1 minus a negative is really a plus, so 1 plus 2 is 3. So then that's 513 times -8, so that's -4,104 over the 3. And that is -1,368. So that is the 9th. I feel like it asked me something else, but maybe not. To find the sum of the first 9 terms. No, that is the sum of the first 9 terms. That's what they want. Example 3. Find the sum of the first 10 terms of a geometric series. So we want S10 in the preceding example. So the same things I was just using, but now we're doing the next one, next number included, so we know the answer is going to be more than this amount. All right, so our a sub 1 was -8. We have our 1 minus our -2. This time it is to the 10th power, and it is 1 minus the, okay, so let's just go ahead and keep that denominator 3. There's no change there. So S10, -8. All right, this one I know is going to be positive, so this will be 1 minus, and again, that's going to be way too big for me to do in my head, 1,024, all right, over the 3. That's going to be a negative, 1,023 times -8, so it's going to be a positive, and then divide that by 3, 2,728 for 10 of them added or multiplied together in the series.